we have with us something called types of cross validation. So what are the types of cross validation? Let me first list them down. First is leave one out cross validation. Next is holdout cross validation. Next, KFold, stratified KFold, and the last is time series cross val. Apart from that, if we come across any other cross validation techniques, we'll be looking into them also. So we have already seen that what cross validations and what is its use. Now let's understand first of all that is basically train test split. So let's say this is our data, and what we'll be doing will be divided into train and test. Now this part will be used for model training and the remaining part will be used for testing. So in holdout, number one which we are going to test in holdout cross val, we'll be doing what? Let's say we divide our data into 70% and 30%. This will be for training and this will be for validation, and we'll be using something called a random state, and based on that this random state our model performance will increase or decrease, and on the selection of this proper random state we'll be using our best model for the selection purpose. So this is how it works. It's similar to this train test split, and which we are dividing into some ratio. Mostly training data will be more than testing data, and random state will be taking randomly. We'll be doing several iterations of random state, and based on that we will try to pick the best model. Okay, next we have something called KFold cross validation. Let's look at KFold cross validation first, then we'll be looking at leave out and KFold satisfied. KFold cross validation. In KFold cross validation, let us say this is our data, and we'll decide, okay, let's say k equals to 4, and this is our data. Now in first iteration we'll be taking this as our validation data and remaining this as training. So this will be used for training and this is used for validation, and this will give us, let's say, accuracy A1. And now second iteration we will be again having our data. This time let's say this portion acts as validation and remaining as what we say, training. So this will give us accuracy A2. Similarly, in the third iteration let's say this will be used for validation and remaining will be used for training. This will give us accuracy A3. Similarly, in the last iteration, what we'll be having, so this is used for validation and this will give us A4 accuracy. So ultimately what we are doing, we are training our model into whole of the data and running what, k iterations with different training and validation data. Okay, now how will we be calculating the average accuracy? We will be doing average of A1, A2, A3 and A4. This is how we will be doing KFold cross validation. In this case, what we will be achieving, that we will be achieving the information about whole data set and our models will be hyperparameter tuned with the help of this. So this is k-fold cross validation. Okay, but what's the problem with this? This may not work in imbalanced data. So what I'm trying to say, let's say you have your data set. This is your data set. Now in this data set, let's say we have a binary class. So basically it is having yes or no, and if we try to visualize that class, we have some graph something like this. This is basically yes and this is no. So what you can see, this data is imbalanced. Yes is having more number and no. So for example, there is certain portion of data where there is 90% of yes. So now if we try to train this model on this data, it will be biased because it's having 90% of yes. So obviously if you're giving any input to this model which is trained on this piece of data, it will be predicting yes because most of the entries are yes here. So this will lead to wrong model training. So to avoid this, what we can do, we can use something called stratified KFold. So what stratified KFold is, let's say visually if we look at that our binary class which we have assumed previously, let's say this is our binary class. Okay, this is no and this is yes. So let's say this is 60% and this is 40%. So in stratified KFold, when we are taking this kind of some random entries, okay, for validation purpose, it will try to maintain this 60:40 ratio. Okay, so it will try to maintain the 60:40 ratio in each in each of the divisions it will be taking on. So this is what stratified KFold is. We'll try to divide our model training and validation data, but we'll try to also maintain this ratio 60:40 so that our model don't get biased, right? So this is stratified KFold. Next one is what we call as P out, or basically if we name it with another which is more general name, let's leave out cross validation. So what we have, we'll be having some value which is called P, and let's say this is our data set. What we'll be doing, we'll be just leaving some P values, some P points for validation, and remaining will be used for training. It's simple. Right. So this is how it's working. Now there is a special case of this. If P equals to 1, what will happen? Each and every time, let's say you have 100 entries, so 99 will be going for training and 1 will be going for testing. So if you want to run it for whole model, it will take how many iterations? It will take 100 iterations. So what's the problem is with this is that if your data set is so long, let's say you are dealing with big data, so there will be billions of entries, and in order to train a model properly, we'll have to run n square iterations, so that won't be computationally efficient. So basically n iterations. So this kind of model cannot be followed in case of big data and all. So there is a one disadvantage of this leave one out cross validation. It is called leave one out cross validation. We are leaving one and revenue will be putting for training purpose. The last thing we need to discuss is called time series. So now let's say how we can understand it. Let's say we have 2 points initially. So what we are doing, we'll be taking one for training, one for testing. Now let's say some other data added. Let's say another data. So what we'll be doing, we'll be taking some of it for training and remaining for testing. Now let's say some more data added. So we'll be doing what? We'll be taking some of it for training and testing. So we are dividing data in sequentially for training and sequentially for training and validation purpose. So this is what time series is. So I think there is pretty much of the topics which we need to see. We'll have a more detailed look on them when we'll work on practical implementation. For the theory part, this is it. Uh, this is the least, or this is the best you can have an intuition of cross validation. Cross validation, if someone asks, then you can say that cross validation is used for hyperparameter tuning and basically validation. Okay, so this is all for this, and next we'll be looking practical implementation of this, and after that we'll be looking across grid search and randomized search and their practical implementation. So that's it for this video. Thank you.